Today I am going to explain you a lesson in chemistry related with chemical calculations. Related with chemical calculations. Because most of the students ask to me to this part because they are having some difficulties about the calculations. Right? Then it is important because if we consider the MCQ paper, most of the problems are related with chemical calculations, as well as in the structure paper also, the essay paper, there are inorganic problems, physical problems also, physical part, all are related with chemical calculations. So it is the main basic part in chemistry. You must understand very well about the chemical calculations. Today I will be going to explain you as well as possible, right? Okay. Then initially I'll explain you how to calculate the concentration. Concentration. Symbol is C. Concentration. So what do you mean by the concentration? If we take an aqueous solution, if the volume is V cubic centimeters, if the number of mole N of the solute, the N is the number of mole of solute. It is the dissolved compound. V is the total volume of the prepared solution. If it's so, we are going to calculate the concentration. Then can be given an equation C equals N over V. Concentration equals number of mole of the solute divided by the total volume of the solution. So what are the units should be taken? N in mole, MOL, all are simple. V should be taken in cubic decimeters. Then what do you mean? So as the concentration, we are going to calculate what is the number of mole, how much of the mole of the solute present in 1 cubic decimeter of the solution. If we take 1 cubic decimeter solution of this solution, 1 cubic decimeter, it is not the given solution, maybe. If we take 1 cubic decimeter, how many moles are present? How many moles are present in this solution? It is the concentration. Then if we want to calculate concentration, what is the unit? Moles per cubic decimeter. It is given as capital M. Moles per cubic decimeter. 1 cubic decimeter contains how many moles of the solute? This is the fundamental equation. Most of the problems are related with this equation. This is the mother equation, fundamental equation. Right? Is it clear? Then, from this equation, cross multiplication can be taken N equals CV. N equals CV. N is the number of mole. How many mole? C is the concentration. Moles per cubic decimeter. V is the volume, should be taken in decimeters, cubic decimeters. If we know the volume of the given solution, We can take any sample of the solution. It is the volume. If we know the concentration of the given solution, we can calculate by the product of CV how many moles of the solute contained in this solution. How many moles? Number of moles. It is very important relation during the calculations. How we calculate? If we want to calculate the number of mole, concentration into volume, volume should be taken in cubic decimeters. Right? These are the fundamentals of the calculations today I will be going to do. Right? Then I'll explain you a problem related with these calculations. Right? I think, is it clear how you calculate the concentration? N over V, moles per cubic decimeter. Volume should be taken in always cubic decimeters. Generally, we are taking as the practical value of the volume cubic centimeters. So we have to convert cubic centimeters into cubic decimeters. Right? It is the weak point, maybe give a mistake. Right? Then, through these fundamentals, I will be going to do a problem for you. Is it clear? Right. So, a problem is given. This is a flask. It contains 0.05 m. It is the concentration. 500 cubic 0.5 m, 100 cubic centimeter. In NaOH, sodium hydroxide. Right? Then it is mixed with 0.01 m, 100 cubic centimeter of sulfuric H2SO4. 0.5 m concentration, 100 cubic centimeter of NaOH mixed with 0.1 m concentration, 100 cubic centimeter of 100 cubic centimeter of not 100, sorry, it is 50 cubic centimeter of sulfuric. 50 cubic centimeter of sulfuric. So the total volume 150 cubic centimeters. Total volume. Then, after the mixing, add distilled water until the volume becomes 250 cubic centimeter. With addition of water, the final volume make the 250. This is the given solution, given problem. Then they ask to calculate final OH minus concentration. How much in the solution? Final OH minus concentration. Na plus ion concentration of the final solution. These are the factors we have to calculate. See here, 0.5 m 100 cubic centimeter NaOH, 0.1 m 50 cubic centimeter sulfuric, mixed together, it becomes 150. After that addition of water, it makes 250. The final volume of the solution is 250. Right. Then, how we enter to this problem? Then, the added reactants NaOH and sulfuric. It is an acid. It is a base. If we mix acid and base, acid-base reaction is occurred in this vessel. Then we must go through the acid-base reaction. We must give the balanced chemical equation for the reaction was occurred in the solution. Right? Then NaOH plus sulfuric H2SO4 to give Na2SO4 plus water. Sodium hydroxide, sulfuric, Na2SO4 is the formula of the sodium sulfate and water. So it is clear that to balance it, Na2, 2NaOH should be present here. Then, the reaction is occurred in the solution. So it is clear that we must go through the stoichiometry of this solution. Stoichiometry of this solution. What is the stoichiometry? It is the simplest molar ratio between the reactants and the products and the reactants and products. See here, 2 moles of NaOH react with 1 mole of sulfuric to give 1 mole of sulfate, sodium sulfate, 1 mole of water. This reaction is occurred always at anywhere if we add any amounts according to that ratio. It is the stoichiometry. Right? Then we must go through this calculation based on this stoichiometric ratio. Then we are going to calculate the number of moles of NaOH. What is the equation related? Do you remember? N equals Cv. Don't write here. Keep in your mind. We are going to calculate the number of moles of NaOH was added. Then N equals Cv. C is the 0.05. Not need the units into 100 cubic centimeter. Divide by 1000. Right? Concentration in moles per cubic decimeter. Volume converts to cubic decimeters. Right? So it becomes 0.005 mole. Now we are going to calculate added. These are the added amounts in NaOH and sulfuric. This line 0.00 mole of NaOH was added. Similarly, how many moles of sulfuric was added? N equals Cv, 0.01 concentration into 50 is the volume, divided by 1000. Then it becomes 0.0 Very sorry, it is 0.02, my dear children. It is 0.02 because we have to go through the given problem. 0.2. Then it becomes 0.001 mole. So it is clear that no. NaOH was added 0.005 mole. Sulfuric was added 0.001 mole. These are the added amounts NaOH and sulfuric. Then, are they react to each other? 0.005 react with 0.001. So we have to decide that. But you must think that, you must know that if we added any amounts, they react according to the stoichiometric ratio. 2:1. If we added any amounts, right? The ratio, they are related to each other. Then, if we think 2 is 0.005, 0.005, 2, the ratio. How much should be the 1? 1 is half of that, 0.0025. If 0.005 undergo the reaction, 0.005 needs 0.025 because 2:1 ratio, according to that ratio. But it is not occurred. It is impossible. Why? NaOH has 0.005 mole, but sulfuric has only 0.001. But for 0.005 it needs 0.025 according to the 2:1 ratio. So it is not occurred. Then we must go from sulfuric to NaOH, other side. The present amount 0.001. 0.001. This is the present moles of sulfuric. 0.001. It is 1. It needs 2 means 0.001. It needs 0.002. 1:2. See here. 0.001 is present amount of sulfuric. It needs 0.02 mole of NaOH according to the stoichiometric ratio. So it is possible because 0.05 mole of NaOH is present in the solution. This is the ratio should be occurred according to the present amounts, right? Then reacted. These are the reacted amounts. 0.02 react with 0.01. Then remained. Ituru naade remained. 0.05 out of 0.05 only react 0.02. It remains 0.03. Then 0.01 is the present amount of sulfuric. Total amount was reacted. No remained of sulfuric. Similarly, in all the cases, it is impossible to remain both. Always only one remain if it is not tally with the stoichiometric ratio. Then, how much of sodium sulfate formed? 2:1:1. Na2SO4, 2 is 0.002, 1 is 0.001. Sodium sulfate also 0.001 should be formed. Right? Then what are the compounds which are formed and present in the final solution? Now, if we go to this solution, now the solution 250 contains Na2SO4 formed 0.001 mole, right? NaOH remained 0.003 mole. These are the formed amount and remained amount in the final solution. Volume is 250, right? So see here how we come to that final decision. According to the stoichiometric ratio, we calculate the number of moles of each adult and how they react to each other according to the stoichiometric ratio. Then due to the large amount of 0.05 of NaOH, it remains 0.03. No sulfuric acid, all are reacted, but sodium sulfate also formed 0.01 mole. Then, now I think you are clear that we can calculate the OH ion concentration and sodium ion concentration of the final solution. Consider the final solution. Na2SO4, it ionizes 2Na plus SO4 2 minus. These ions are present for the Na2SO4. One ionizes to give 2 Na plus mole, SO4 1 mole. But it is clear that solution contains 0.001 mole was formed, then it should be given 1:2, 0.002 mole. Then the solution contains sodium ion mole 0.002 was given by sodium sulfate. Then NaOH also remained. It ionizes to give Na plus OH minus. 1 mole gives 1 and 1. Remains how much? 0.003 mole. Then how many OH minus also formed? 0.003. Because ionization occurs 1:1. It gives sodium ions also 0.003. Then sodium sulfate gives 0.002 mole of Na plus. Sodium hydroxide is given 0.003 mole of Na plus. Altogether, total Na plus addition of 0.02 plus 0.03, 0.005 total amount of Na plus present in the final solution. Then we can give the concentration of Na plus. C equals N over V. So N is C Na plus concentration, right, equals in 0.005 divided by volume 250. 250 divided by 1000. This is in mole. This is in cubic decimeters. So it is clear that 0.005 into 1000 divided by 500 is the calculation. Then 500 into 2, it is equal 0.01. The concentration moles per cubic decimeter. Right? Then how we calculate the OH ion concentration? OH ions are given only by sodium hydroxide. The total amount 003. Therefore, OH minus concentration equals number of moles 0.003 divided by 250 divided by 1000 as here. Mole cubic decimeters. So it becomes 0.012 moles per cubic decimeter. This is the concentration, this is the calculation of the concentration problem. So it is clear that I think you must go through for the calculations. The foundation is stoichiometric ratio of the reaction. It is very important, otherwise you can't do it. Right? Then, my dear children, I will go to do another type of problem related with the stoichiometric ratio in solid form. In solid form. It is given as a mixture of calcium carbonate, solid, and magnesium carbonate, solid. That solid mixture has the total mass 0.92 grams. 0.92 grams. Then, on heating, they undergo the thermal decomposition. Carbonate dissociate to give calcium oxide, solid plus carbon dioxide giving out gas. It is balanced. MgCO3 also undergoes decomposition, giving MgO solid plus CO2 gas. In the problem, the residue is the remainder also given as 0.48 grams. It is the given problem. The solid mixture contains calcium carbonate and magnesium carbonate 0.92 grams. They undergo the thermal decomposition, giving the residue. It is given the residue. We must identify the residue. Calcium oxide and magnesium oxide 0.48, giving out carbon dioxide. These are the balance equations for the problem. Balance equations for the problem. Right? Then you have to calculate the mass percentage of calcium carbonate of the initial mixture. Mass percentage of calcium carbonate of the initial mixture. You have to calculate. Then we must go through the balance equations. The total marks 30 was given. Out of 30, now you have obtained 10 marks for the balanced two equations. Right? Then it is very important to start the problem with the balanced chemical equations. Right? So the states are not essential, but it is important to know us because you have to identify the residue. Residue is the remainder. Remainder should be solid. Right? Then, for the calculation through the equation, it is better, it is easy to go through the moles. 1 mole of calcium carbonate gives 1 mole of calcium oxide. 1 mole of magnesium carbonate gives 1 mole of MgO solid. If we assume X mole of calcium carbonate was taken, Y moles of magnesium carbonate also taken. X and Y are initial number of moles of calcium carbonate and magnesium carbonate of the initial mixture. Then calcium oxide also X mole, magnesium oxide also Y mole. It is clear, I think, because 1:1. Then we must give the relation between X and Y with the 0.92, X and Y with the 0.48, two equations. If we are able to write two equations, to give two equations related with X and Y, two unknowns, we can calculate X and Y. Is the best method, easiest method. So see here, 0.92 gram is the total mass. Then X is the number of moles of calcium carbonate. Therefore, how many grams of this mole? How many grams of calcium carbonate present here? If we know the mole, how to calculate the number of amount in grams? You know that calcium carbonate has the molar mass 40 plus 12 plus 16 into 3 48, altogether gives 100 grams. It is the 1 mole. Similarly, magnesium carbonate also having, you can calculate 84 gram as 1 mole. If it is 1 mole, 100 grams, X moles, 100, X is the amount in grams. Here also, 84, Y is the amount in grams. So it is clear that calcium carbonate X moles having 100 X grams, magnesium carbonate Y mole having 84 Y grams. The total mass is 0.92. Then what is the relation? So 100x mass of calcium carbonate plus 84y mass of magnesium carbonate equals total mass 0.92. This is the first equation. Similarly, calcium oxide has the 56 grams. 56 exceeds the number of grams. Here the 40y is the amount in grams. Similarly, here also can be given 56x grams is the mass of calcium oxide. 40 gram is the magnesium oxide. The total mass 0.48. So the second equation 56x plus 40 y equals 0.48. It is the second equation. Right? Then it is clear that now you are obtained two equations, two relations with the given data. Then you have to calculate x and y. You have two equations. Now, out of the 30 marks, now you had obtained 20 marks. 20 marks. Right? For the balance equations, for the given two relations. You had obtained 20 marks out of 30. Then other 10 you can obtain after the calculation. So it is clear that you are having the ability to solve these two problems. Then they asked to give mass percentage of calcium carbonate only. So y is not required to calculate. You have to calculate x only. Then go through this problem to remove y. Using the mathematical relations, remove y and find out x. Then x is the number of moles of calcium carbonate and 100x gives the gram. Total mass 0.92. Then if we know the mass of calcium carbonate, you can give the answer. Then here, see here, we had not written any word. Any word. This the method should be given. So it is clear that total mass, here total mass, not need to write this, let the number of moles of calcium carbonate as x, not need to write, because you are given here. Then this the method should be given when you doing the problems in your exam. It is very easy, takes a little time, it is clear for you as well as examiner also. Right? Then today I had explained two simple equations for the calculations, to start the chemical calculations. Then I think you are clear that on the given two problems. The next day, by my next second video, I hope to explain you redox equations, the problems which are related with the redox equations, and I will be going through the chemical calculations further with you, my dear children. Right? Thank you for all. We will meet from my next video recently. Thank you all of you.